Alright, so in this video we're going to do some review about linear equations, namely going over the different forms you might see a linear equation in, how to go back and forth between these forms, and how to solve some problems that are all about linear equations. Okay, so there's a couple of different forms you might see for equations of lines. The kind of most common form is the slope-intercept form, and that looks like y equals mx plus b, where m is the slope of the line, and b is the y-intercept. So b is the y-intercept. And what that means is if we've got a line over here, that's not very bright. Let's use white on our black background. It's probably better. So here's our axes, and let's draw in a line, something like that. There's our line. Then our point, one of the points on our line is going to be here at 0b, 0, b, from the y-intercept, and our slope is going to be m. So that means that if I were to say plug in 1, then up here I'm going to have the point 1 and then b plus m. So I'll have gone up a unit of, that's pretty hard to read. Let's fix that. I'll have gone up a unit of m for every 1 over I go in the x. So this little triangle right here kind of helps us see what the slope is. This is 1, and this is a unit of m. And it could be up or down, right? Because if m is negative, then that means our line's going to be angled down. Another form you might see for a line is ax plus by equals c, where a, b, and c are all integers. Let's erase that. All integers, meaning whole numbers. This doesn't always work, right? Because you can have lines that don't have nice whole numbers, but in our example, in most cases, we're going to be dealing with just integers or fractional slopes and stuff like that. In which case, we can always find a, b, and c to be integers. And there's one last little condition. This is a choice. Is that our a value is positive. Because if a is negative, we can always multiply this whole equation by -1, and that will change a to be a positive number. Okay, so that's our standard or general form. And then a third form that's pretty handy, because we're often given some information about a line and we have to come up with an equation, is the point slope form, where we've got an x and a y coordinates for a point. So x1, y1 is a point on the line. It can be any point, and m is our slope. Oops, I was using m for red for slope earlier anyway. M is the slope. So same m as slog. Slope. Same m as in the slope-intercept form. And this is just a handy equation. These two equations are the same. It's just a handy equation for coming up with the equation of a line. When you know the point, you know the slope. You just plug those things in and you're good to go. Okay. Alright, so let's look at some examples. Alright, so first example is to derive the slope-intercept form from the point-slope form. So what does that mean? Well, we're going to be starting off, so we're starting with the point-slope form. Oh boy, this is a little messy right here. Derive slope-intercept form from point-slope form. Okay, it's a little confusing to read. So we're starting here, start, and we're trying to finish here, finish. So point-slope form looks something like y equals mx minus x1 plus y1. And what do we know? Okay, so we're going to start off with a line with some slope and a particular y-intercept. As long as the line is not a vertical line, so a vertical line, something that looks like that, it's always going to have a y-intercept. It's always going to pass through some point on the y-axis. And we're going to call that point it passes through 0b. So if we use point-slope form, that's this one up here, we have an equation for the line, y equals m x minus x1 plus y1. And I color-coded this for a reason. We're going to say, we're going to use the point 0, b for our, for x1 and y1. So 0b is on the line, so we can plug it in for x1 and y1. So that's what it looks like now. Y equals mx minus 0 plus b. And anything minus, any number minus 0 is just that original number. So we can say, well, x minus 0, that's just equal to x. So what does this equation become? Y equals mx plus b. And so we get the slope-intercept equation from point-slope form when we plug in the particular point, which is the y-intercept. So we get slope-intercept, I'll abbreviate, from point-slope form. Point-slope form when we plug in the y-intercept. All right. Okay, let's look at another example. What are the slope and y-intercept for a line satisfying the equation ax plus by equals c? So hopefully you recognize that this here is our standard or general form for a line. Standard form. And given the standard form, what is the slope of that line using a, b, or c? And what is the y-intercept using a, b, or c? All right. So the strategy, how we go about doing this, is we need to get it into slope-intercept form. And to do that, you're going to solve it for y. So get y all by itself. And once we've got y all by itself, we should be able to identify what the slope is and identify what the y-intercept is. Okay? All right, so we're starting off with ax plus by equals c. One thing we can do to get y by itself, or a place to start, is subtract ax from both sides. So that eliminates ax from the left-hand side, and that gives us something that looks like this. By equals negative ax plus c. And we have one more step to do to get y by itself. Divide everything by b. So I'm going to divide this whole side by b. Oops, b. And that's going to give me y. And it's easy to kind of forget that when I'm dividing this entire right-hand side by b, that means to divide both of our pieces of the sum by b. So minus ax plus c divided by b, well, it's the same as minus a over b x plus c over b. Okay? Both of them get divided by b, not just the ax term and not just the c term. So now we're in slope-intercept form. We don't have m's and b's, but we should be able to identify that this here is our slope. And this here is our y-intercept. The slope is equal to negative a over b, and y-intercept is equal to c over b.